In this video, I want to talk about some 3D figures that you need to be familiar with, and we're going to go over some equations so you know how to calculate the volume and the surface area of these figures. And we're going to talk about how to distinguish or how to calculate the number of faces, edges, and vertices in some 3D shapes that we're going to consider today, and also in how it relates to Euler's formula. So let's go ahead and begin. The first shape that you need to be familiar with is the sphere. It's a three-dimensional object. The circle is two-dimensional. And so here's how we can draw the sphere. It looks like a circle, but I'm going to draw these lines to indicate that this is a sphere. Now you need to know that the volume of a sphere is 4/3 pi r cubed, and the surface area is 4 pi r squared, where r is the radius of the sphere. So make sure you write these things down because you need to know them if you have a test on it. Now the next figure we need to talk about is the cylinder. And it looks like this. This is just a rough sketch. So this is the radius of the cylinder, and here we have the height of the cylinder. The volume of a cylinder, it's the area of the base, where the base is basically a circle. The area of a circle is pi r squared. It's the area of the base times the height. So the base is pi r squared, and the height is just h. So that's how you can calculate the volume of a cylinder. To calculate the total surface area of a cylinder, it's the area of the base plus the lateral surface area. Now the area of the base is pi r squared, but notice that we have two bases, one on top and the one on the bottom. So it's 2 pi r squared. The lateral area is the product of the circumference of the circle times the height. So this is the distance around the circle is the circumference, and the circumference of a circle is 2 pi r. So you could use this equation to calculate the total surface area of a cylinder. Now the next figure that we need to discuss is the cone. So a cone has a circular base, and this is the radius of the cone, and here this is the height of the cone. So notice that we have a right triangle. So this is r, and this is h. Now the hypotenuse of this right triangle is known as the slant height, which is L. The volume of a cone is 1/3 of the volume of a cylinder. So it's 1/3 pi r squared times the height. Now the surface area is the area of the base plus the lateral area. Just like before, we know the area of the base is the area of the circle. And there's only one circle this time, not two like in the last problem. So it's 1 pi r squared as opposed to 2 pi r squared. Now the lateral area is the area around the cone, and it's 1/2 the perimeter times the slant height. The perimeter of a circle is 2 pi r. Keep in mind the perimeter is basically the circumference of a circle. And the slant height, that's just L. So we can cancel 1/2 and 2. Half of 2 is 1. So the surface area of a cone works out to be this equation. It's pi r squared times pi r L. Now how can we calculate the slant height? The slant height L, you could find it based on the right triangle. You can use the Pythagorean theorem to get it. So for a right triangle, c squared is equal to a squared plus b squared. And c is the hypotenuse, which correlates to the slant height. So L squared is equal to R squared plus H squared. So you can use this to calculate the slant height, and once you have that, you can calculate the surface area of the cone. And then you can easily calculate the volume of a cone using that formula. Now let's move on to the next shape. And this is the rectangular prism. So let's draw this first. So let's call this the length, the width, and the height. The volume of a rectangular prism is simply the product of those three values. It's the length times the width times the height. Now what about the surface area? How can we calculate that? Well, first, we need to add up the area of all 6 faces. So let's start with the face in the front and the one in the back. Notice that the area of each of those faces is the width times the height, where the height is h. And there's 2 of them, so it's going to be 2WH. So that's the area of the front and the back. Now let's calculate the area of the sides. So let's say the front side and the back side, or the side on the left. So notice that it has the length L and the height h. So the area of those 2 sides is going to be LH but times 2, or 2LH. And then we need to calculate the area of the top face and the bottom face. So it's the width times the length, and then times 2. So that's going to be 2LW. So this will give you the surface area of a rectangular prism. Now sometimes you may need to calculate the length of the diagonal. Let's call it D. If you ever need to do that, here's the formula you need. D is equal to the square root of L squared plus W squared plus H squared. And so that's how you can calculate the length of the diagonal of a rectangular prism. Now the next shape we need to talk about is the triangular prism. Now there's multiple ways in which we can draw this figure. So one way we can draw it is like this. The base could be a right triangle. It can be an equilateral triangle. So it could be many things. So in this example, let's say that this is the base, this is the height, and this is the height of the prism itself, which I'm going to distinguish it from this H by using capital H. Now we can also draw a triangular prism, like this. So this would still be H. In this case, this is the base, and this would be the height of the triangle. Now the volume of a triangular prism is the base times the height. Capital B is the area of the base, and the area of the base can vary. In this case, it's simply the area of a triangle. For a right triangle, you can calculate the area using this formula. It's 1/2 base times height. So this would equal capital B. Now let's say if you have an equilateral triangle where all 3 sides are the same. The area is the square root of 3/4 times s squared. Now let's say if you had a triangle where you have 2 sides and the included angle, the area is 1/2 AB sine of angle C. Now if you have a triangle like this, let's say if you know the base and the height, you could simply use A is equal to 1/2 BH. Now sometimes you may have a triangle where you're given all three sides, and let's say all three sides are different. If you need to calculate the area of this triangle, you need to calculate S first, which is 1/2 of the perimeter of the triangle. And then you can use Heron's formula to calculate the area. It's S times S minus A times S minus B times S minus C. And that result is all within the square root. So that's another way in which you can calculate the area of the triangle. So once you find the area, you can replace B with it, and then you can calculate the volume of a triangular prism. Now sometimes you might see a triangular prism drawn this way. And so you're still dealing with the same type of shape. This is the height of the prism. This is the base of the triangle, and you could say this is the height of the triangle. Now let's go back to this figure. How can we calculate the surface area of a triangular prism? Now keep in mind the formula can vary. This is the base, this is the height, and this is the height of the prism. The general formula is this: the surface area is the area of the base plus the lateral area. Now the area of the base is going to change depending on what type of triangle you have. Is it a right triangle? Do you have all three sides? Are the three sides different, the same? And so this can vary. But for this particular triangle, I'm just going to give you an example. The area of the base is going to be the area of the triangle, which is 1/2 base times height. Now there's two of them. We have the triangle on the left and on the right. So we got to multiply that by 2. So for this particular example, capital B is 2 times 1/2 BH. Now the lateral area is going to be the area of the other three sides, or three faces rather. Let's call the third side of the triangle L. So since we have a right triangle, L squared is equal to B squared plus H squared. So if we wish to calculate the area of this face right here, the top face, it's going to be L times the height of the prism. So that's LH. Now let's say if we want to calculate the area of the face in the back, which is this face right here. It has a height H and another side length, which is lowercase h. So it's going to be H times H. And then if we want to calculate the area of the bottom face, it still has a height H, but a width of lowercase b. So it's going to be BH. So notice that it's basically the perimeter of the triangle, which is the sum of those three sides, H, L, and B, times the height of the prism. If you factor out capital H, you could see that P is equal to L plus H plus B. So for this particular example, the lateral area is capital H times L plus H plus B, and I'm running out of space. So thus we have the surface area is B times H plus L plus H plus B times the height of the prism. So make sure you know this. The lateral area is going to be the perimeter times the height. And so this is the surface area for this particular type of triangular prism. And you could use the general equation for all types of triangular prisms. Now there's one more shape that I want to cover, and it's the square pyramid. So it's a pyramid with the base of a square. So I'm going to draw it like this. So let's call this B, and this is going to be B as well. That's the length of the base. And here we have the height of the pyramid, which I'm going to call H. And this part here, that's half of B. If this whole thing is B, and this is the center, then this part here is, that's going to be B over 2. And then this part is the slant height, which we can call L. And this is the right triangle. Now the volume of a square-based pyramid is going to be 1/3 times the area of the base times the height of the pyramid. Now the base is a square, and the area of a square is length times width, or B times B, which is B squared. So capital B is equal to lowercase b squared. That's the area of the base, or the area of the square. So times the height. So therefore the volume of a square-based pyramid is 1/3 b squared times h, where lowercase b is the length of the square on the bottom. Now what about the surface area of a square-based pyramid? Well, we can use the general form for the surface area of any 3D shape. It's the area of the base plus the lateral area. Now we know the area of the base is b squared, but what's the lateral area? Well, notice that there's 4 faces of 4 triangular faces with 1 square face on the bottom. So I'm going to draw one of those 4 triangular faces. The height of that triangular face is the slant height, which is L. And it has a base, B. Now we know that the area of a triangle is 1/2 base times height. The base B is the same, but the height is no longer H, it's the slant height L. Now notice that we have 4 of those triangular faces. So this is one of them. Here's the second one. That's the one in the front. Then we have the one on the left side. That's the third one. And then there's the one in the back, the fourth one. So the lateral area is going to be this times 4. So it's 4 times 1/2 BL. And 4 times a half, or 4 divided by 2, is 2. So this is the surface area of a square-based pyramid. It's b squared plus 2bl, where L is the slant height. Now how can we calculate the slant height? Let's focus on this right triangle. And so c squared is equal to a squared plus b squared, according to the Pythagorean theorem. But c is the slant height, a, which we'll call b over 2, and let's square that, and then b will be h. So if you need to find the volume, you could use that equation. If you need to calculate the surface area, first you need to calculate the slant height using the height of the pyramid and the base of the pyramid. Once you have the slant height, you could plug it into this equation to calculate the surface area. So if you want to combine these two equations into one, first we need to solve for L, taking the square root of both sides. So then you'll get this equation. L is the square root of, this becomes b squared over 4 once you square it, plus h squared. So I'm going to replace L with this equation. And first let's make some space. So you could say the surface area is b squared plus 2b times the square root of b squared over 4 plus h squared. So this will give you the surface area simply using the base and the height of the square pyramid. So here we have a rough sketch of a cube. And what do you think the volume and the surface area of a cube is going to be? Well, let's say the side length is x. Just like a rectangular prism, the volume is going to be length times width times height. So it's x times x times x. So the volume of a cube, it's x cubed, where x is the side length. Now what about the surface area of a cube? Well, for a rectangular prism, we saw it was 2L plus 2W plus 2LH. In this case, it's going to be 2x squared, or like 2 times x, but 3 times. So the surface area of a cube is 6x squared. So make sure you know these formulas. Now let's talk about the faces, the edges, and the vertices of a cube. This picture was a lot better than the last one. Let's call this A, B, C, and D. And this is going to be E, F, G, and H. So what are some of the faces of the cube? How many faces does it have? So notice that we have the face in the front. This is face A, B, C, D. Another one is the one on the side, D, C, G, H. That's this one. So a face is basically a flat surface. It's two-dimensional. Now how many faces do we have in this cube? So we saw that A, B, C, D was one face. That was the one in the front. We also have E, F, G, H in the back. That's 2. On the right we have C, D, H, G. That's 3. On the left, A, B, F, E. That's 4. The bottom, A, D, H, E. That's 5. And the one on the top, B, C, G, F. That's 6. So let's say that F is equal to 6. Now what about the number of edges? So what are some edges in this cube? Segment AB is an edge, so we can represent it like this. BC is also an edge. And CD, that's an edge as well. So let's calculate the total number of edges. So AB is 1, BC is 2, CD is 3, AD is 4, and then we have AE, which is 5, EH is 6, DH is 7, GH is 8, CG is 9, FG is 10, BF is 11, and in the back we have EF, which is 12. So a cube has 12 edges. Now what about the vertices? How many vertices does it have? So in a cube, you can identify a vertex where 3 edges meet. So A is a vertex. So it's one of the vertices. So this is 1. B is another one. That's 2, 3, 4, 5, 6, 7, 8. So there's 8 vertices in a cube. Now Euler's formula tells us that the sum of the faces and the vertices minus the number of edges is equal to 2. So in this case we have 6 faces, 8 vertices, and 12 edges. 6 plus 8 is 14. 14 minus 12 does equal 2. And so this is in harmony with Euler's formula for figures like these that are just made up of faces. Now let's apply it for a triangular prism. So let's call this A, B, C, D, E, and F. So what are some faces in this problem. So notice that ABC is one face of the triangle. Another face that we have is DEF. And also, we could say BEFC is a face of this triangular prism. Now let's calculate the total number of faces. So the first one, as you said, was ABC. The second one, DEF. The third, BEFC. Now a fourth one is the one on the bottom, ADFC. And then the one on the back left, ABED. So that's the fifth one. There's a total of 5 faces in this figure. Now what about edges? Let's name some edges. So AB is an edge. We could say that BE is an edge and DF is an edge. So we can write them this way. Now let's calculate the total number of edges. So this is 1, 2, let me write them. So this is AB is 1, BC is 2, AC is 3. DE is 4, EF is 5, DF is 6. BE is 7, AD is 8, CF is 9. So I calculated a total of 9 edges. Now the vertices, we just got to count the letters, because that's where 3 edges will meet. So this is 1, 2, 3, 4, 5, 6. So I counted 6 vertices. Now let's use Euler's formula to confirm that this is equal to 2. So the faces plus the vertices minus the edge lengths has to equal 2. So we have 5 faces, 6 vertices, and 9 edges. 5 plus 6 is 11. 11 minus 9 is 2. So this is in harmony with Euler's formula. Now let's go over one more example. And so that is the square-based pyramid. So let's call this A, B, C, D, and E. So let's calculate the number of faces. So we have face ABCD. That's the base of the pyramid. Another face is AEB. That's 2. And then EBC is another one. So that's 3. And then ECD. That's 4. And then the one in the back, EAD. That's 5. So there are 5 faces in this figure. Now the number of vertices are the letters A, B, C, D, E. So there's 5 vertices. Now how many edges are there? So we have edge AB, that's 1. AE, that's another one. BE, that's number 3. Let's use a different color. BC is 4. EC is 5. DC is 6. AD is 7. And then ED is 8. So I got a total of 8 edges. So the faces and the vertices minus the edges has to equal 2. So F is 5, V is 5, and E is 8. 5 plus 5 is 10. 10 minus 8 is 2. So this is another figure that works in harmony with Euler's formula. And so that's it for this video. Hopefully it gave you a good introduction into 3D shapes such as spheres, cylinders, cones, rectangular prisms, square-based pyramids, and things like that. So thanks for watching.